Good afternoon, colleagues. Today we have here Alexandra Avdeeva. Just welcome her. And she is a PhD student at HSC University Moscow, and where she is doing PhD from Institute of Astronomy of Russian Academy of Science in Assam. So her research interests inclined to sky surveys, astrostatistics, and machine learning. She is the part of our recently accepted BRICS project titled Search and Follow-up Studies of Time Domain Astronomical Sources using Sky Survey, BRICS Telescope, and Artificial Intelligence Subsystem. So two more contributors are who have contributed in this work, Oleg Malko and S. Karpro. So she will be talking about the objects with extreme UV emission in modern sky surveys. So they have found some new sources, and they are planning to submit the observing proposal to AstroSat for the further investigation. So I welcome to Alexandra.
Yes, thank you very much for introduction, and I also want to say good afternoon to everyone. And I want to express my deep gratitude to Dr. Santosh Doshi, who invited me today, and for all the people who take care of me here, because it's my first time in India and first time in Aries, and I enjoy my experience very much. So yes, as it has been already said, I will be talking about the work we have done in the frames of our joint BRICS project, and it is about searching for objects with extreme ultraviolet emission. Okay, too much. So let me start with a bit of context. Large-scale modern surveys that covers a broad range of spectrum have revolutionized astronomy. They have revolutionized our ability to study the vast amount of objects. Among these objects, the most favorable one and the most convenient are the ones who can be found in different surveys, like, for example, in optics, in SDSS, in pulsars and DES, in UV, in GALEX, in gamma rays in Fermi, and in infrared in WISE and TMAS. Because with this photometry, we can reconstruct the spectral energy distribution, which is essentially allows us to know about the star, its temperature, its class, to classify it more specifically, and even know what extinction the star is undergoing. However, objects that are found only in one survey exclusively and absent in all others should also take our close attention, because this is the source of potential discoveries. We, in this work, are specifically looking for objects that are found only in GALEX data, so only in ultraviolet range, and absent in two major optical sky surveys, pulsars and dark energy survey. First, a bit about GALEX. GALEX is a ultraviolet space observatory, which has been in operation for almost a decade. And two valuable legacies of GALEX for our work are the catalog produced from images, and also a database of photon called GPhoton. It contains all the photons ever detected by GALEX with time and direction from which the photon arrived. So it allows to reconstruct both images in different epochs and light curves if there is enough points. GALEX see the sky in two distant UV bands, far UV and near UV, which are located in the transparency window between Lyman break and alpha break. And these UV bands are quite distant from typical Sloan, quasi-Sloan filters, right here, which are typical for modern optical survey, including pulsars and DES. Let's now take a look at the two-color diagram to get more understanding what objects we are looking for. This diagram was produced as the result of cross-matching of GALEX and SDSS. So here you can see loci of hot stars, and here in black loci of galaxies. From the limited magnitudes of both GALEX and optical sky surveys, we can estimate what color should our extreme ultraviolet object have, should they have, to be like invisible in optical surveys, but visible in ultraviolet. And they should have near UV minus G color less than -2 or -4. So these should be well above this loci, something outside of the plot. When it comes to large-scale cross-matching of modern sky surveys, there are several approaches widely used. First one is to simply download all the databases to your computer and perform all the computations locally. This allows a great flexibility, and you can do whatever you want computations and enhance your cross-match with various specifications and so on. However, you should be aware that huge tables takes a lot of storage space, and also sometimes the computational capabilities. So this can be inconvenient for some cases. Another approach is to use online services. It's approach which is gaining popularity lately. You can use online services like MAST or NoriLab, where the data is already stored in some databases, and you can just submit your task and it will be executed somewhere else, and then return with you with the result. Also, they sometimes provide a very nice visual representation of your data. However, none of this had our all free catalogs we need. On the other hand, CDS offers catalog storage Vizier that have all of catalogs we need, and it also offers cross-matching service, well-tested and reliable Xmatch, which contains all catalogs, but it does not have does not allow some arbitrary computation and does not allow you to submit your tasks. However, we decided to give it a try, and to proceed with Xmatch. I want to remind you that we don't want to simply cross-match catalogs. We want to find unmatches. And the first problem we encountered right at the very beginning is that the footprints of catalogs can be, of course, different. For example, pulsars in green covers all the northern hemisphere and part of the southern hemisphere, while the footprints of DES in orange and the footprints of GALEX in blue and light blue are more complex and patchy. So we want to find objects that have objects in GALEX that have no matches in pulsars and DES, and objects in this zone will naturally be those because they simply are outside of the footprint of optical surveys. And this is not what we wanted to do, because we want to find objects that have no counterparts for physical reasons. So we came up with an algorithm, simple yet very effective. which allows us to divide the problem of unmatching down to cross matches. And here is how it works. Firstly, we start with broader cross match with a radius of 30 arc seconds around our GALEX object, just to find if this object is within the footprint of the optical survey, either band stars or DES. Then we proceed with smaller cross match with the radius of 3 arc seconds, which is suggested by the investigator of GALEX to find the exact match. So exactly the same object in the optical survey. And to obtain our final list of possible candidates, we simply discard second result from the first result. And this leaves us only with objects that are within the footprint of optical survey, but have no exact counterpart for this ultraviolet object. After this procedure, we apply additional criteria to be sure that our findings are exactly what we want to do and not some contaminations. We essentially applying GALEX quantity flags, like we filter out all the objects with non-zero extraction flags, which can be possibly raised due to contamination, due to blending from nearby sources, or if the object possibly on the edge of was on the edge of the image. We also filter out all the objects that have flags assigned by GALEX, suggesting that these objects, this detection can be potential artifact due to dichroic or window edge reflection. Also, we keep only those objects with sufficient signal to noise, and we decide to filter out all the objects with signal to noise ratio lower than 5. So we do not obtain noise detections, and also we get rid of extended objects. Because we are only interested in point-like sources in this work, and actually gross match of extended object is a bit more complicated. So to get rid of extended objects, we compare the magnitude of an object within Cron aperture, which was designed for extended objects, and compare the 4-pixel aperture. If they differ too much, this means, like here, if they differ too much, this means that it's probably extended object. And if it's differ less than, we have this value minus 0.3, we think that this is a point-like source, and we keep it.
So it was not part of the catalog, this circular aperture and extended aperture, right? You created.
There's both of these apertures are a part of the catalog. We just made like discard one from another.
So I thought you were just working on the ASCII catalogues, the
Yes,
coordinates,
yes,
and
yes.
point sources, exclusive sources,
Yes.
and you were not working on the images.
At this point, no, but later we will be working with images. So yes, the next step is to filter, to perform filtering by optical images. So to find cases where objects can be in fact in the place in, for example, this, like here, but it escaped automatic detection. It could be due to object being too bright, so it will be masked, or if there are two objects like here, like here. Due to several reasons, they can be their footprints can be complex and remains of and artifacts. And also, we have inspected if there is no situation while object is visible but too faint that it escaped automatic detection. Moreover, we have checked for blended objects because angular resolution of GALEX is much lower than those in optical survey. This could be the case where two objects in depth could be blended into one object in near UV. So they will be not much due to this reason. So to do this, we have searched for all peaks in the central region of DES and Panster images, and then performed an flux weighted average. So we have calculated the centroid, and we also do this for different UV to optical flux ratios, because for different stars they can be different. And then compare this space of potential positions of centroid with near UV source position, and made a conclusion on if it could be possible that these several, two or maybe more objects are blended in one or not.
So you de-blended them and catalogue using fluxes separately for further study.
Yes, yes. Another potential distraction is the proper motion of stars. As we are working with catalogues that have been observed in different epochs, for example, the maximum span could be up to 15 years. The star can actually undergo significant motion and simply move from its place that was visible in while GALEX operated. Fortunately, we have Gaia now, which measures proper motion for the majority of brighter and nearby stars. So we checked Gaia if it has object with proper motion more than 0.1 arc seconds per year within the radius of 30 arc seconds. And if so, we also filter out such objects as potential contamination. Another potential distraction is a phenomenon, an anomaly, which has already been known after a coarse sun point event in May 2010. Some ghosts appeared on the images of GALEX, meaning that the bright objects start to have some companion, which is not an object in fact. So we checked for such objects also, like here, for example, one of our findings. We have an object in near UV, but not have an object in DES. And with G-photon, we were able to reconstruct images from 27 and 2011. And we saw that in 27, there was no object, and in 2011, the object appeared. And with a broader image, it turned out that it is actually not an object itself, but a ghost. Because in this region, a lot of bright sources have a ghost, all of them marked in red circles. So we checked if our finding have another one brighter object nearby, brighter at least by 3 magnitude, within the distant range from 30 to 90 arc seconds. And so we filter out the objects that have this bright companion, which is an object indeed. Then we checked our findings more closely with G-photon package, which allows, as I said, to reconstruct images in different visits of GALEX, like here. With precise time of observation in GALEX, so we are able also to check if the source is from solar region, like asteroid here. So we marked asteroids separately, asteroids. And after all this filtering, we came up with a final list of candidates. From the intersection of GALEX and DES, which together spans roughly 5,000 square meters, we get 27 known asteroids and one stationary object. By stationary object, I mean the object that have persistent UV magnitude for at least several subsequent visits of GALEX. And from the intersection of Pan stars, which are about 5 times more larger than those with DES, we get a lot more asteroids, 58 transients, 86 stationary objects as this one, and 8 single epoch observation, meaning that we cannot decide whether it's a transient or a stationary object. No wonder why Pan stars brought more asteroids. They naturally came from the ecliptics, and the coverage of ecliptic in DES is very small, here dots in red. And the coverage of ecliptic in Pan stars is quite sufficient. We also can see here the distribution of our findings by magnitudes, meaning that stationary objects are mostly faint, and the transient one can be much brighter. Let's now take a closer look at our findings. Here we have a stationary object. The first one is from DES. This is some UV source on the outskirts of some galaxy, which makes him an intriguing object to further observations. And we also have some objects from Pan stars. Here you can see that there is a faint, small dot. So maybe the object is visible, but it's very, very faint, or maybe it's a contamination. But this suggests us that these could be either very hot stars or maybe some active galactic nuclei. The transient behavior is a bit more diverse. For example, this on the left, it appeared within the 2 hours, and its brightness increased drastically. And then several years later, the object was not there. Other objects we have found behaviors differently. So there was no object in 24, but in 25, at the end of December, it was already there, and it was already there for at least 20 days. Unfortunately, the most time of GALEX operation was before the emergence of modern time domain surveys like ZTF or SSN. So it's not possible to uncover right now the nature of this phenomenon. Oh yes, and now I'm ready to came to conclusions. To sum up, in this work we introduced we have introduced an approach of finding the unique objects in one survey that is absent in all other surveys. With this technique, we have found some reliable candidates of stable UV objects, as well as a number of transients. The candidates we selected, we think that they require additional investigation using probably X-ray sources, X-ray data, or follow-up observation using UV facilities available now. Specifically, we are very much hoping to proceed with a good proposal for astrosats in the upcoming year. Thank you very much. In case there are any questions, I will be happy to.
So thank you, Aleksandra. So now questions from Auditorium. Jivan.
For the cross matching, you mentioned that we started from the 30 arc second, then the 3 arc second, then the smaller one, right? Why this 30 arc second? Why not the smaller one?
Yes, as I explained, we want to make sure that our UV source is actually within the footprint of optical survey. Let me go to the map of yes, here it is, of star distribution. If we just start with 3 arc second cross matching, we will obtain all of these objects because they are out of footprint of our pulsar stars and their catalogues. But this is not the result we want to get, because we want to get objects that have no counterpart for the meaningful physical reasons. And this is the reason that it's just
30 arc second seems to be too large. That's what I must be.
Well, for the footprint,
Right.
well, I guess it seems well, it seems okay to me.
Okay.
That's to make sure that it's in footprint, but not too large to like touch other footprints. Well, on the edges, of some surveys, it might happen, but for the majority of cases, I guess that's okay.
For the multiple identification, multiple cross matching, the
two stars are close to each other. Means the two stars, two sources are close to your target source. So how do you assure that which one is its counterpart?
Well, for the GALEX, it's usually one counterpart within 3 arc seconds. Not more than one usually, but the very common situation is that there are 2 objects like here, 2 objects in optic like here. They will be blended to one in the GALEX data. So we additionally checked for that.
That depends on the special resolution of the telescope, right?
Yes, of course. Of course, if there are 2 objects that it's most likely they are blended. At final list, we have no candidates with more than well, we have no candidates with any number of counterparts, because we are looking for objects with no counterparts. Well, actually, the decision of whether the object, whether first one or second one match is right, it's not well interesting for us. If there are matches within 3 arc seconds, we just filter this out, and that's all. Because we're looking for the ones with no counterparts.
Do you have any statistical or do you have any probability to say that many objects, this object is very close to that one? That some statistical criteria that you applied and said that, okay, now this is the reason.
Can you please specify?
I mean
more?
is that, for example, if two sources are closer to your target source, so you may say that one source is, let's say, 90% closer to this, other source is, let's say, 50% closer to this, then 90% closer source is much more probable counterpart.
Well, in this specific task, again, we are not interested in this because we want to came up only with objects that have no counterparts at all. But if we're like doing cross match for other tasks, then we check the magnitudes as well, how well they are going with each other, to understand which object is more probable to be the counterpart. So I guess this is the main.
Regarding to your this finding the new sources which have no counterpart, as you mentioned that there are the ghost images, right? Ghost objects.
Yes, ghosts.
Right.
Correct.
So are you sure that these are the ghosts? They may be the transient.
Wow. This is, I guess, probable. Well, let's go to the ghost part. Yes, this is probable, but I guess very unlikely because as you see the specifically on this image, several objects have a ghost in a particular place, like towards the real object. But we probably could have filtered out some.
That's surprising actually. There are only the few sources have the ghost images, but another source doesn't have there. So 1, 2, 3, 4, 5 sources were there only.
Four.
Yeah.
Yes. Well, yes, maybe some of them. There is possibility that some of them are real sources indeed. But we wanted to make sure that we find a real object, and for this purpose we have to sacrifice these several ones.
Yeah.
Yes.
So what I understood that you are searching for a optical counterparts of the GALEX sources, right?
Yes.
So what kind of sources are these? And once you have a sample of these sources, like optical counterpart plus GALEX flux, so what you are going to do with that sample, like some are transient or some are have counterparts, then what you will do?
Well, we want to study it more closely, to study them maybe with additional data. It is probable that this object have X-ray emission large enough. Yes.
So but only there will be early time stars, like massive stars or like initial stage of their evolution.
Can you please specify?
Like this UV emission will come in the early time stars, like massive stars. So in late time stars, UV emission will be very less. The probability of getting the counterpart, optical counterpart is very less in the late time star. So your selection is biased toward the massive or early time stars, right?
Yes, yes, of course.
So and then you will have a sample of optical counterpart of a massive or early type stars, what you are dealing with. So you once you have this sample, what you will do?
What is the problem you're addressing?
Once you detected these sources, what is your future plan?
What is the physics problem you're trying to address?
How you are going to address? What are the physics you are going to draw with these sources?
Well, right now we are not able to say what. Well, maybe these are the hot stars or young star objects. Not young star objects. I'm sorry. Massive stars or active galaxy nuclei. So at first we want to try to know which of them are what. Maybe with additional observations, if possible, and then to figure out what to do next.
So still, they are not sure whether they are the Asian or massive stars or whatever. There would be some. So they want to investigate them. What kind of source you have?
Did you have not attempted yet on the X-ray contact, right?
Yes.
That will be also important.
Of course.
So any further questions? Not? Then again, thanks to speaker.
Thanks
It's
very
not-
much for the audience.
Thank you.
Thank you very much.
Later,